Preface. About this book. Persistent memory is often referred to as non-volatile memory, NVM, or storage class memory, SCM. In this book, we purposefully use persistent memory as an all-encompassing term to represent all the current and future memory technologies that fall under this umbrella. This book introduces the persistent memory technology and provides answers to key questions. For software developers, those questions include: what is persistent memory? How do I use it? What APIs and libraries are available? What benefits can it provide for my application? What new programming methods do I need to learn? How do I design applications to use persistent memory? Where can I find information, documentation, and help? System and cloud architects will be provided with answers to questions such as: what is persistent memory? How does it work? How is it different than DRAM or SSD, NVMe storage devices? What are the hardware and operating system requirements? What applications need or could benefit from persistent memory? Can my existing applications use persistent memory without being modified? Persistent memory is not a plug-and-play technology for software applications. Although it may look and feel like traditional DRAM memory, applications need to be modified to fully utilize the persistence feature of persistent memory. That is not to say that applications cannot run unmodified on systems with persistent memory installed. They can, but they will not see the full potential of what persistent memory offers without code modification. Thankfully, server and operating system vendors collaborated very early in the design phase and already have products available on the market. Linux and Microsoft Windows already provide native support for persistent memory technologies. Many popular virtualization technologies also support persistent memory. For ISVs and the developer community at large, the journey is just beginning. Some software has already been modified and is available on the market. However, it will take time for the enterprise and cloud computing industries to adopt and make the hardware available to the general marketplace. ISVs and software developers need time to understand what changes to existing applications are required and implement them. To make the required development work easier, Intel developed and open-sourced the Persistent Memory Development Kit, PMDK. Available from https://p-mem.io/pmdk. We introduce the PMDK in more detail in Chapter 5 and walk through most of the available libraries in subsequent chapters. Each chapter provides an in-depth guide so developers can understand what library or libraries to use. PMDK is a set of open-source libraries and tools based on the Storage Networking Industry Association, SNIA, NVM programming model designed and implemented by over 50 industry partners. The latest NVM programming model document can be found at https://www.snia.org/tech_activities/standards/cur_standards/npm. The model describes how software can utilize persistent memory features and enables designers to develop APIs that take advantage of NVM features and performance. Available for both Linux and Windows, PMDK facilitates persistent memory programming adoption with higher-level language support. C and C++ support is fully validated. Support for other languages such as Java and Python is work in progress at the time this book was written. Other languages are expected to also adopt the programming model and provide native persistent memory APIs for developers. The PMDK development team welcomes and encourages new contributions to core code, new language bindings, or new storage engines for the persistent memory key value store called PMEMK versus. This book assumes no prior knowledge of persistent memory hardware devices or software development. The book layout allows you to freely navigate the content in the order you want. It is not required to read all chapters in order, though we do build upon concepts and knowledge described in previous chapters. In such cases, we make backward and forward references to relevant chapters and sections so you can learn or refresh your memory. Book structure. This book has 19 chapters, each one focusing on a different topic. The book has 3 main sections. Chapters 1 to 4 provide an introduction to persistent memory architecture, hardware, and operating system support. Chapters 5 to 16 allow developers to understand the PMDK libraries and how to use them in applications. Finally, Chapters 17 to 19 provide information on advanced topics such as ROS and replication of data using RDMA. Chapter 1. Introduction to Persistent Memory. Introduces persistent memory and dips our toes in the water with a simple persistent key value store example using libpmemk versus. Chapter 2. Persistent Memory Architecture. Describes the persistent memory architecture and focuses on the hardware requirements developers should know. Chapter 3. Operating System Support for Persistent Memory. Provides information relating to operating system changes, new features, and how persistent memory is seen by the OS. Chapter 4. Fundamental Concepts of Persistent Memory Programming. Builds on the first 3 chapters and describes the fundamental concepts of persistent memory programming. Chapter 5. Introducing the Persistent Memory Development Kit, PMDK. Introduces the Persistent Memory Development Kit, PMDK, a suite of libraries to assist software developers. Chapter 6. libpmem. Low-level persistent memory support. Describes and shows how to use libpmem from the PMDK, a low-level library providing persistent memory support. Chapter 7. libpmem-obj. A native transactional object store. Provides information and examples using libpmem-obj, a C native object store library from the PMDK. Chapter 8. libpmem-obj-cpp. The Adaptable Language, C++ and Persistent Memory. Demonstrates the C++ libpmem-obj-cpp object store from the PMDK, built using C++ headers on top of libpmem-obj. Chapter 9. pmemkv. A persistent in-memory key value store. Expands upon the introduction to libpmemkv from Chapter 1 with a more in-depth discussion using examples. Chapter 10. Volatile Use of Persistent Memory. This chapter is for those who want to take advantage of persistent memory but do not require data to be stored persistently. libmemkind is a user-extensible heap manager built on top of Jamalloc which enables control of memory characteristics and a partitioning of the heap between different kinds of memory, including persistent memory. libvmemcache is an embeddable and lightweight in-memory caching solution. It is designed to fully take advantage of large-capacity memory, such as persistent memory with DACs, through memory mapping in an efficient and scalable way. Chapter 11. Designing Data Structures for Persistent Memory. Provides a wealth of information for designing data structures for persistent memory. Chapter 12. Debugging Persistent Memory Applications. Introduces tools and walks through several examples for how software developers can debug persistent memory-enabled applications. Chapter 13. Enabling Persistence Using a Real-World Application. Discusses how a real-world application was modified to enable persistent memory features. Chapter 14. Concurrency and Persistent Memory. Describes how concurrency in applications should be implemented for use with persistent memory. Chapter 15. Profiling and Performance. Teaches performance concepts and demonstrates how to use the Intel vTune suite of tools to profile systems and applications before and after code changes are made. Chapter 16. PMDK Internals. Important Algorithms and Data Structures. Takes us on a deep dive of the PMDK design, architecture, algorithms, and memory allocator implementation. Chapter 17. Reliability, Availability, and Serviceability, RAS. Describes the implementation of reliability, availability, and serviceability, RAS, with the hardware and operating system layers. Chapter 18. Remote Persistent Memory. Discusses how applications can scale out across multiple systems using local and remote persistent memory. Chapter 19. Advanced Topics. Describes things such as no-ma, using software volume managers, and the mmap, map_sync flag. The appendixes have separate procedures for installing the PMDK and utilities required for managing persistent memory. We also included an update for Java and the future of the RDMA protocols. All of this content is considered temporal, so we did not want to include it in the main body of the book. Intended audience. This book has been written for experienced application developers in mind. We intend the content to be useful to a wider readership such as system administrators and architects, students, lecturers, and academic research fellows to name but a few. System designers, kernel developers, and anyone with a vested or passing interest in this emerging technology will find something useful within this book. Every reader will learn what persistent memory is, how it works, and how operating systems and applications can utilize it. Provisioning and managing persistent memory are vendor-specific, so we include some resources in the appendix sections to avoid overcomplicating the main chapter content. Application developers will learn, by example, how to integrate persistent memory into existing or new applications. We use examples extensively throughout this book using a variety of libraries available within the Persistent Memory Development Kit, PMDK. Example code is provided in a variety of programming languages such as C, C++, JavaScript, and others. We want developers to feel comfortable using these libraries in their own projects. The book provides extensive links to resources where you can find help and information. System administrators and architects of cloud, high-performance computing, and enterprise environments can use most of the content of this book to understand persistent memory features and benefits to support applications and developers. Imagine being able to deploy more virtual machines per physical server or provide applications with this new memory storage tier such that they can keep more data closer to the CPU or restart in a fraction of the time they could before while keeping a warm cache of data. Students, lecturers, and academic research fellows will also benefit from many chapters within this book. Computer science classes can learn about the hardware, operating system features, and programming techniques. Lecturers are free to use the content in student classes or to form the basis of research projects such as new persistent memory file systems, algorithms, or caching implementations. We introduce tools that profile the server and applications to better understand CPU, memory, and disk I/O access patterns. Using this knowledge, we show how applications can be modified to take full advantage of persistence using the Persistent Memory Development Kit, PMDK. A future reference. The book content has been written to provide value for many years. Industry specifications such as ACPI, UEFI, and the SNIA non-volatile programming model will, unless otherwise stated by the specification, remain backward compatible as new versions are released. If new form factors are introduced, the approach to programming remains the same. We do not limit ourselves to one specific persistent memory vendor or implementation. In places where it is necessary to describe vendor-specific features or implementations, we specifically call this out as it may change between vendors or between product generations. We encourage you to read the vendor documentation for the persistent memory product to learn more. Developers using the Persistent Memory Development Kit, PMDK, will retain a stable API interface. PMDK will deliver new features and performance improvements with each major release. It will evolve with new persistent memory products, CPU instructions, platform designs, industry specifications, and operating system feature support. Source code examples. Concepts and source code samples within this book adhere to the vendor-neutral SNIA non-volatile memory programming model. SNIA, which is the Storage Networking Industry Association, is a nonprofit global organization dedicated to developing standards and education programs to advance storage and information technology. The model was designed, developed, and is maintained by the SNIA NVM Technical Working Group, TWG, which includes many leading operating system, hardware, and server vendors. You can join this group or find information at https://www.snia.org/forums/c/nvmp. The code examples provided with this book have been tested and validated using Intel Optane DC persistent memory. Since the PMDK is vendor neutral, they will also work on NVDIMM devices. PMDK will support any future persistent memory product that enters the market. The code examples used throughout this book are current at the time of publication. All code examples have been validated and tested to ensure they compile and execute without error. For brevity, some of the examples in this book use assert statements to indicate unexpected errors. Any production code would likely replace these with the appropriate error handling actions, which would include friendlier error messages and appropriate error recovery actions. Additionally, some of the code examples use different mount points to represent persistent memory-aware file systems, for example, DAXFs, PMEMFs, and MNT, PMEMFS. This demonstrates persistent memory file systems can be mounted and named appropriately for the application, just like regular block-based file systems. Source code is from the repository that accompanies this book. https://github.com/apres/programming-persistent-memory. Since this is a rapidly evolving technology, the software and APIs references throughout this book may change over time. While every effort is made to be backward compatible, sometimes software must evolve and invalidate previous versions. For this reason, it is therefore expected that some of the code samples may not compile on newer hardware or operating systems and may need to be changed accordingly. Book conventions. This book uses several conventions to draw your attention to specific pieces of information. The convention used depends on the type of information displayed. Computer commands. Commands, programming library, and API function references may be presented in line with the paragraph text using a monospaced font. For example, to illustrate how persistent memory is used, let's start with a sample program demonstrating the key value store provided by a library called libpmemk versus computer terminal output. Computer terminal output is usually taken directly from a computer terminal presented in a monospaced font, such as the following example demonstrating cloning the Persistent Memory Development Kit, PMDK, from the GitHub project. $git clone https://github.com/p-mem/pmdk cloning into PMDK. Remote. Enumerating objects. 12. Done. Remote. Counting objects. 100%. 12/12ths, done. Remote. Compressing objects. 100%, 10/10ths, done. Remote. Total 100169. Delta 2, reused 7, Delta 2, pack reused 100,157 receiving objects. 100%, 100,169 100,169ths. 34.71 megabytes. 4.85 megabytes per second, done. Resolving deltas. 100%, 83,447 83,447ths, done. Source code. Source code examples taken from the accompanying GitHub repository are shown with relevant line numbers in a monospaced font. Below each code listing is a reference to the line number or line number range with a brief description. Code comments use language native styling. Most languages use the same syntax. Single-line comments will use, and block, multi-line comments should use. An example is shown in Listing 1. Listing 1. A sample program using libpmemkv. Include iostream. Include libpmemkv. H. Using namespace pmemkv. kvprint. Print a single key value pair. Void kvprint. Const string and k. Const string and v. std::cout key. K. Value. V. Line 45. Here we define a small helper routine, kvprint, which prints a key value pair when called. Notes. We use a standard format for notes, cautions, and tips when we want to direct your attention to an important point, for example. Notes are tips, shortcuts, or alternative approaches to the current discussion topic. Ignoring a note should have no negative consequences, but you might miss out on a nugget of information that makes your life easier.